to be here to actually get the class starting. So in 9 minutes time we'll start. So we just have 4 person here. All right. Yeah, all right. Night again, class. Is everyone hearing me?
Yes, I am. Good night.
Yeah, man, night. Yeah, so I think tonight things are gonna shift a little bit over to the hybrid side of things. All right, so I'm not sure if anyone here is familiar with the hybrid and electric vehicles. That's what we're gonna get into tonight. Okay. All right, so the objective of this is to describe PPE used when servicing HV vehicle. So the PPE is personal protective equipment like your gloves, hard helmets, your hard boots, and those safety gears. And the HV here is high voltage. All right, so describe PPE used when servicing high voltage vehicle. System demonstrate the use of HV PPE and perform HV vehicle safety disconnect procedure. Explain procedures while servicing HV vehicles. Compare HV safety disconnect procedures. So high voltage safety procedures. All right, so high voltage safety rules these are stuff that you will probably see on poster when you enter these work here. So the safety rules are as follow. You are responsible for your own safety and safety of others. So your safety is your responsibility as well as others in your surrounding. All right, so wear personal protective equipment necessary for the job. So you're gonna choose the safety equipments them that you need to carry out a particular duty. So you're gonna choose those equipment based on the task guide. Always use equipment, tool, machinery safely and properly. So we are gonna use the tool them what they for what they are required for. Okay, so we'll always use them in the correct and safe way. All right, so no misuse of tool. All right, lift properly using your legs and not your back. And that's supposed to be a safe rule right across the board, whether you're working on hybrid or just general lifting. We must know that we lift with our knees and not our back. Keep your work area clean, wear appropriate and safe work clothing and footwear. All right. So with electric and hybrid vehicle, we don't normally wear like steel toes. We wear composite toes. So we wear composite boots. That hard section at the toe is not made of steel, but more of composite material, or like a hard type of plastic. All right. And report any unsafe condition. So once you're in the work area and you observe something that you know can pose some sort of risk, you should report that immediately and say clean up spills immediately. So you're actually gonna work tidy. Just like as a rule 5 said, keep your work area clean. All right. So report all injuries. So if you find that our colleagues of yours actually is being injured, you can report that immediately to your superior. All right. No alcohol or drugs to be used or allowed on company property. So no use of banned substances. So high voltage when servicing any full electric vehicle, EV, as short or hybrid, you will be dealing with high voltage. These voltages can range from 40 volt to 800 DC volts. Please note these voltages are potentially fatal. And these are the categories for the voltage, and you can see the different volt range and what are their impacts on the human body. So these voltage are in milliamp and their effects. So 1 milliamp, we can just feel current. 5 to 10 milliamp, increase in pain, can't let go. All right. 20 to 50 milliamp, we'll feel like severe pain, muscular contracts, possible fatal. So there's a possibility that this could cause death. And from 60 to 100 millivolts, we can have tissue destruction, breathing stop, probably fatal. At 100 volt though, milliamp I should say, well, that can be fatal. So once 100 can be fatal, the 8000 can also be fatal as well. So effect of electric current on the human body. So current level milliamp, and this is just an a more breakdown layout of that. So below one milliamp, generally not perceptible, and 1 milliamp might feel a faint tingle. 5 milliamp, slight shock, but not painful or disturbing. So average individual can let go of the current source. However, strong involuntary action can lead to other injuries. So so what I mean by that is because I actually feel that slight shock, yeah, I tend to want to pull your arm away from that, and you actually can injure yourself doing that. Just from that natural reflex. All right, 6 to 25 milliamp, painful shock, loss of muscular control. All right, so with that, you can actually falter and literally don't have no control over yourself. So you like you have a seizure. 9 to 49 milliamp, the freezing current. So the freezing current are let go range. The average individual cannot let go, but can be thrown from the current source. So this are the range now where if you actually like hold on to the wire, it's like you can't let go. Somebody after come on like probably bounce with piece of board or something, and for you to let go. Now from 50 to 150 milliamp, extreme pain, respiratory arrest, severe muscular contraction that is possible. And we have from 151 to 2,000 milliamp, rhythmic pumping action of the heart, seizures and muscular contract and nerve damage occur. That is likely. So this is a level where we're gonna have muscle and tissue damage. And this is where it's gonna start to affect the heart. Above 2,000 milliamp, cardiac arrest, internal organ damage, and severe burn. That is probably right. So here we have the types of safety gear or PPE, personal protective equipment. So we have our insulated gloves, and we have our cotton gloves right here, and we have our outer protective gloves. We have our meter. This is an alligator clip. And we have our overboot. So you can wear your actual shoes within the shoes. So it's like a shoes for a shoe. And we have our insulated tool, our tool pan, face shield, and zip tie bags and tag. Let's see. All right. Those are just some of the stuff, safety stuff. We have a lot more than those. So you can actually research on those. So type of safety gloves, so electrical safety gloves. These are the first line of defense for contact with energized components. So because our hand is more likely to is what you're going to most likely to use to actually touch these components. The gloves will be your first line of defense against high voltage wires and components. So most EV manufacturers recommend that insulated rubber gloves should be worn when working near all high voltage components, not just the vehicle batteries. All right, so once you're actually dealing with the EV vehicle itself or hybrid, it is recommended that we always wear insulated gloves. Ordinary latex gloves are not thick enough and do not provide sufficient protection from the shock hazard. All right, so with our ordinary latex gloves, that is not enough to protect us from these hazard. They're not thick enough. All right, so cotton undergloves to be worn underneath electrical safety gloves and leather gloves. Or cotton undergloves not only reduce sweating, they give added comfort and protection to the PPE user in warm and humid conditions. All right, so the cotton gloves is actually very important. And as I can see, when you're actually purchasing gloves, like for an individual, we're gonna we're gonna buy them in different size, meaning the cotton gloves are gonna fit right to your palm, snug. Then you're gonna buy the insulated gloves that it can actually fit over the cotton gloves. So if you should put your beer on in it, it's gonna fit loose. So once you put it on the cotton gloves, it's gonna compensate for that looseness. And then the outer gloves now, or the leather gloves, are actually can fit over those two as well. Alright, so you're not gonna buy them at your exact fit. Only the cotton gloves will be an exact fit. But the insulated gloves and the leather over gloves will actually, you're gonna buy them like a size up from your hand size. Try them actually wear over each other. And the good thing about the cotton gloves is because your hand will sweat. If you have sweat actually running down the side of your hand, that will actually create a path for electric, or it will actually create a conductor. So you actually at risk if you have sweat dripping over the circuits, you actually can short circuit stuff. And as I say, I can expose yourself to an electric shock. So the cotton gloves, you can see the importance of that. And the leather over gloves now, these are worn over insulating gloves to protect against mechanical hazard and electrical harm. Alright, so if we don't have the leather over gloves, so I got me now we have actually puncture the insulated gloves, right? Because those are rubbers and we can work with like sharp objects and stuff like that. So we wear the leather gloves to protect us, protect the insulated gloves from being punctured. And this is how it looks. So I have our cotton gloves, then we'll put our insulated gloves on after. And then our leather over gloves. And if you notice how them do this, the technician actually in long sleeve and I'm actually tucking. So that really even help with sweating. If you don't like the feel of a cotton gloves under the insulated gloves, just make sure say the sleeve actually tucked in to actually absorb that sweat, because usually it kind of feel awkward having on so many gloves at once and you're actually dealing with these wired kind of when you bend your fingers and those stuff, it can actually feel awkward. So as I was said, cotton gloves is just for added comfort. And this is our storage bag after use. We inspect our PPE and then once we're satisfied with the inspection, we can place them back in the bag for safekeeping. Alright, so glove specifications info. Alright, so when it comes on to electric and hybrid vehicle, the class that we actually focus on is class 0 as it pertains to gloves. The gloves will fall into the class 0 or category 0. Alright, so what that means is this is class 0, the second line. So here we have our class of equipments. We have class 00, which is the maximum use voltage AC is 500. And the proof test is 2500 AC volts. And proof test with DC volts is 10,000. All right. But the class that we actually focus on is class 0 for hybrid and electric vehicle, based on the volt range as I said, can go up to 800 volts. So the maximum use voltage for this, for the class 0, is 1000 AC and 5000 proof test. So them actually penetrate it with 5000 when they are proof testing it. So it actually way above what you are going to actually use it for. So you're well safe using these gloves. All right, once they are not punctured or out of date. All right, so and it is actually proof test DC voltage 20,000 volts. All right. Yeah. And the other categories, also don't focus on this other one. It's just class 0. All right, so on the gloves, we'll actually have a tag. That's an information tag we can use to actually know the type gloves, the category it is in, and the size. So here we have the product code. All right, so we have the manufacturer code right here. We have the class. So as I can see, it's a class 0 category. And here we have the glove size. Right. And we have the gloves length. So yeah. And we have the manufacturer dates. So the month and the year. So it's March 2020. Right. And then we have the International Technical Commission code right here. All right, so this code is actually the code for gloves. So it's 60903. So this code is something you need to remember. All right. Yeah. All right. So like for safety tools, they will actually have their own different code. Sorry. So I think the standard for tools is 06900. That for insulated tools. So you'll actually get these standard as we go along. Everyone is hearing me?
Yes, I am.
Oh, just checking.
The radio mode up. The Bluetooth device is connected successfully.
All right, so before and after each use of the gloves, a test is required. All right, so we normally test the gloves before I use them and after. So test at required intervals. All right. Use accredited test lab. So we have interval in which we have to actually test these gloves. All right. So I think it's like 6 months after the seal is broken. So after you pull it out of the original package seal, we test those like every 6 months at a lab to make sure that they are still up to standard. All right, and we use trusted labs to do that. So I just bring it around the corner because we know that somebody can do it. All right, and we use gloves from the right classification. As I will say, category 0. All right, inspect before each use. So ear test gloves for leak. So we actually can use like a gloves pump. We have a pump that can fit where your palm actually enters the gloves. And just to see if we have any air leak, or if we don't have those type of tool, you can just simply blow in it. All right, and close off the palm section just to make sure that it is not leaking. All right, so the two last one is what we normally do before and after use. All right, and here we have now other personal protective equipment. So we have our face shield. All right, so this part of equipment is extremely important when working on high voltage, as it protects the eyes from any flashover that can occur if an electrical spark is produced. The face shield provides forehead and protection of full 180 field of vision. So unlike the safety goggles, you don't get like a full 180 vision, because I know the side part is actually going to give you like a blind spot. So with this, you actually have a better sight of vision in this. Right, so and it actually protect the face and the forehead as well. And we don't get that from wearing safety goggles. All right, so dielectric overboot. So this to be worn over existing footwear. The dielectric overboot provides additional protection and insulation, preventing electric shock should a vehicle technician encounter contact with live electric source. So we can have on our composite hard boot, and for like added protection, if you want to be like real safe, you can put on this dielectric overboot as well. And it actually protects it from like spillage. Just the way it is locked to the foot. So dielectric material is a type of insulator which become polarized when it comes in contact with electrical source. All right. All right, so this is our face shield and our dielectric boots. And as you can see, this face shield here actually protects the skull as well. And the overboot, as you can see, protects from spillage as well. So you don't have to worry about chemicals damaging your uniform or anything like that. Alright, so insulating rubber apron manufactured from 1 mm thick orange neoprene with nylon insert for added strength. This apron is to protect the technician working with live voltage up to 1000 volts. All right, so it's basically it's like an apron, but it's made of rubber. All right, just for added safety. And these are high voltage resistant tools. All right, and this will be the information section on the tool that can. So as I can see, so with insulated gloves, The standard for insulated gloves, as I said, is 609903, and for insulated tools, it doesn't matter what type of tool it is governed under 60900. All right, so you can see it right here. Like I can get it any bigger. And so those are insulated spanners, and this is going to be our insulated socket set. So this is our ratchet angle. We have our ratchet angle here, and this is our socket inside. And sometimes these tools, you can get them like composite, meaning they don't have any metal, they don't have no metal structure. And you can get them like metal with composite coating. But the full composite types, they are way more expensive. So the more budget friendly one would be like the coated composite type. But like, so like this one, the socket here is of metal, and then the rest of it is composite. And then let's do this for strength. Sorry. And we have our extension in this one, ratchet angle, as you can see. Once the socket is fitted to the angle, you actually have no metal here actually exposing, right? We have our torqued and Allen key set. And now that this falls under category the standard 06900. All right, so these are some other safety stuff. So we have our first aid kit, as well as a spill kit. We have our sign, and this is a rescue hook. And we use this hook just in case somebody is being electrocuted. We use this to actually pull them away from that. So that's why it is called a rescue hook. All right. We have our insulated caps. So like once you pull, remove connectors or wires, we actually use these insulated caps to prevent short circuit. We have our cones, and to actually card off the ear. So once you're going to work on a EV vehicle, we normally set up for a caution zone, right? So we would place the necessary signs around that area, right? So this is where you're going to actually protect. So this is where the protection of others in the work area comes in play. So once you card off the area, it actually warn others that you're actually working on a high voltage system. All right. And this is the service plug. So all electric and hybrid vehicle actually has a service plug. So in other words, it's like a service breaker. So once you pull that breaker, it chill the system. And we normally put like the fob or the key in a safety box. We call this the lockout tag out box, right? So that put that away from the vehicle and lock it so somebody don't accidentally go and actually take up the key and then come energize the vehicle while you are working on it. All right, and we have a rubber insulated mat. So just like the dielectric boot, we can actually place this mat on the ground and stand on it for added security or protection, as well as we can actually spread it on the table and put our battery pack on it and actually disassemble it on it, because we don't want to be dismantling the battery on a metal surface, or if it even a wooden surface, we wouldn't want it to be damped. So to be safer, just use that mat. And here we have our gloves box. So those are just some of the added stuff that we use when working on these vehicles. And this is an example of the work here actually set up with the vehicle in it that is being working on. So as you can see, we have our cardinal here. We have a danger sign at the front, right? And we have our next danger sign around the back. And as I can see, a door is somewhere close to here. So that will be warning persons who are entering from the back as well as the front that work is in progress with the high voltage system, right? And as I can see in this one, we have a lift here. So some of these battery, they can be extremely heavy. So we actually have a crane we use to move those battery around to actually either place them on a workbench or wherever we're gonna work on them. All right, and we always recommend to have a fire extinguisher in close proximity, and it's good to have it near an exit. So as you're running towards the exit, you can actually have a fire extinguisher. You don't put it in an enclosed area where you can actually trap yourself in case you have a fire. All right. All right. So when we work on electric vehicle, we have our one and rule. All right. And the importance of this is when using a multimeter, the one and rule prevents current from flowing in one arm through the heart and out the other arm. Keep one hand in your pocket. All right. So this is an example of that. So as I can see in the image, the first image here, one hand in the pocket and one hand using the meter. So if you remember, your body is a natural conductor of current. So if current should accidentally, for example, your gloves got damaged or puncture without you knowing, instead of to have current flowing through your heart, we use a one hand rule. So one hand in the pocket and then one hand doing what you're doing. So the current will flow through the arm and down in the leg and to ground. All right. Example 2, you have no one in the pocket. So the current just flow across. And that will go straight to the heart and then out through your next arm. And that can be fatal. This is it. If you should step on high voltage wire, the current will actually go from one leg to the other. All right. All right. So fluke is at the top when it come on to voltmeter. That's a second. Sorry about that. But we're not saying that you have to have a fluke, but once the burn of a tool is not really as important, it's just that fluke is more of a household name. But once it is in the right category, as I was saying, when it comes on to the voltmeter, unlike the safety gloves that is in category 0, when it comes on to the voltmeter now, it's going to be a category 3. All right. So the category 3, as I can see in this area, we have category 4, we have category 3, right? So that means it can handle up to 1,000 AC volts, right? As well as the leads were able to handle that amount of voltage as well. All right, so this is the category here that we are going to focus on, category 3. So this is not as clear, but we're going to try and read it. So category 3, the 3-phase distribution, including single-phase commercial lighting. Right, so we know with motors, we normally have like single and 3-phase motor, and those use AC voltage. So, right, so we have equipment in fixed installation such as switch gear and polyphase motor. All right. So bus and feeder in industrial plant, feeders and short bench circuit, distribution panel devices, lighting systems in larger buildings, appliance outlets with short connections to service entrance. So I think there are just even some examples as to where this category can be used. All right, so when you come on to our voltmeter and our voltmeter leads, the category 3 is what we actually focus on. All right, our class 0. But you now really see class 0 and the voltmeter, it will come in category. So unlike the other stuff, you will see class. With the voltmeter, you're going to see category. So once it's a category, we're going to look for category 3 or above. All right. I don't know, once we're dealing with electrical stuff that can cause fire, we have to have an extinguisher that actually can deal with combustible metals. All right. So class B powder is what we use to extinguish fire in high voltage system. All right, so now we have other extinguisher like our class A and B, class A, B, C, which combination of class A, B, C that can be used to actually extinguish electrical fire, but not combustible metals. All right, so when we actually go, like we set up our work here, our card off the stuff them and stuff like that, we actually have procedures now. So we have to actually know how to carry out. So like our safety procedure, part of that is the safe shutting down of the vehicle. So vehicle shutdown procedure, we call it the safing. So perform diagnostic first. So before we shut down the vehicle, if we have like a check light on the vehicle or any other warning light, we're going to retrieve those code first, because we know like when we pull out the battery or pull off some other high voltage system, then we realize, oh, we never scan the vehicle, so we have to end up fitting back those, because once we pull back the vehicle, those components actually missing. Those are actually show a code as well, so we're not gonna know where we're at. So we're gonna retrieve our codes first. All right. And after we do that, we are going to shut down the vehicle with the key, move the smart key to a location at least 1 meter away. All right. You know, so some of them smart key here we call fob. You have to then within a certain range. So once you're within a certain range, the vehicle can actually start. If you accidentally like press the start button with your foot on the brake. All right, so try start in case other key is nearby. So once you remove the main key or the key that the customer actually bring the vehicle with, yeah, actually when you lock away that key, you're gonna try and start it again. Because sometimes the customer may very well have a second key in the gloves box or somewhere, just to make sure that there's no key in the car. So once you try to start it again and it don't start, and know so well, you're good where that is concerned. All right, so after that now we're gonna disconnect the 12-volt battery, sometimes called auxiliary battery. Well, it's widely called auxiliary battery when it comes to hybrid and electric vehicles. That's the term we are going to mostly see. So, I really see the 12-volt battery, I just say auxiliary battery. All right, so the auxiliary battery can be under the bonnet, sometime under the seat, which is the back seat, or in the trunk. So it can be located anywhere in the vehicle. All right, so this is like a little story as it pertains to not safely shutting down the vehicle before you actually start to work on it. And when you come on to hybrid, working on it not necessarily mean that you're going to actually be pulling out the battery. You can just be doing a basic service like an oil change. So this is going to be a story about that, what can happen if you fail to do this safely shut down the vehicle and remove the keys. So a bad day changing oil. A shop owner was asked by a regular customer who had just bought a Prius if the oil could be changed there. The owner opens the hood, made sure the filter was in stock. It is a standard Toyota filter used on other models, and said yes. The technician, with no prior knowledge of hybrid, drove the warm-up vehicle into the service bay. The internal combustion engine never started, as it was in electric stealth mode at the time. So the thing with hybrid, sometimes it go in stealth mode, meaning it's running on the motor side, right? So if somebody should like drive up, you're not gonna hear the vehicle, and then probably after a while, you're gonna hear the engine chipping. So this is what I know. Him bring the vehicle in the service bay, and it did in a stealth mode, right? All right, so not hearing the engine running, the technician hoists the vehicle into the air, removes the drain bolt, and drains the oil into the oil pan unit. When the filter was removed, oil started to fly around the shop. The engine was in standby mode during the first part of the oil change. When the voltage level dropped, the onboard computer starts the engine so that the hybrid could recharge. The technician should have removed the key to keep this from happening. Be sure that the ready light is off before changing the oil or doing any other service work that may cause personal harm or harm to the vehicle in the engine, if the engine starts. So basically him start drain the oil and stuff and the engine just start on him while I'm under the car. So him actually could harm himself as well as damage the vehicle itself. But it can actually damage the bearings or seize other moving parts because it literally drain out the oil. Alright. Plus the vehicle is hot. So, you know, so oil gonna start spraying out through the filter mount and all these things. So you have to make sure so the ready light is off. Once the vehicle starts, a ready light will come up on the display to show say the vehicle is actually on. But this is all because he never have prior knowledge of an hybrid vehicle. So basically, him is ignorant to the vehicle that he's working on. And as a result, him learned the hard way. Right, so jacking and lifting, especially in command to pure electric vehicle. Those have their battery underneath the car itself. The floor of the car, the bed of the car. So you know go on just shove your jack under the car and just jack it up, but you can actually damage stuff underneath the vehicle. So the jacking and lifting is important of these vehicles. So carefully follow the vehicles or highest manufacturer lifting instruction. Two reasons for this. This prevents any damage to high voltage cable or battery pack located under the vehicle. If battery pack removal is necessary, the ice arm will be out of the way. Right? So once you put the ice arm under the vehicle, you have to be careful, make sure you put it on the jacking points. So all the person when you like bend, you have to bend. Alright, so this is the example of a jacking point. So the green areas are appropriate lift areas. The yellow area are safe stabilization point for a Model S resting on its side. All right. And that orange zone, high voltage battery. So you see how close the battery actually run towards beside the jacking points. So in a mishap, we have disaster. So you could just be doing like a tire change and then you damage the battery components. Damage the battery components and a job would probably charge 2,000 probably cost you a couple hundred well. Alright, all because of negligence. So we have to be careful when jacking up pure electric vehicles. The hybrid, you can get away with it the way or you jack it up, but with the hybrid, we still have high voltage cables running under them. But it is more, but you have to be extremely careful when working on pure electric. All right, so high voltage disconnect procedure. Although the safety, plug, location, and physical appearance may be different, they they all perform the same function, disconnecting the high voltage system. Yes, so most of them come in orange. So it's that same device that I was showing you earlier, that I was saying you can actually look at it as a circuit breaker, where you actually break the circuits, right? And you lock away that in a box with the key. All right. So read the service information for the particular vehicle you are servicing to locate the service procedure, or to locate the procedure. Sorry. So because you have different vehicle have these service plug at different location, the easiest way to find them is in the service manual. All right. Where safety gloves and glasses. And I was also we know the importance of those. With that note, so moving over a little to more to safety again. So in case you have a fire, right? Fire safety and fire extinguisher use. All right, so fire triangle, we know, so we actually have to have 3 elements in order to create fire. We have to have oxygen, and we have to have fuel and heat. And fuel necessarily mean gas. It can be a piece of plastic, it can be a piece of paper, dry wood, or anything that is combustible. It can be looked at as fuel. All right, and heat can be heat in itself, or it can just be a spark. We know we have abundance in oxygen, so the fire now go short of that. All right, so once we have those 3 in the triangle, we can actually start a fire. The 3 components need all 3 components to start a fire. Fire extinguishers remove 1 or more of the component. So the extinguisher actually suppress 1 or 2 of these in order to extinguish the fire. Right, so types of fire, and we have our classes. And this is actually important because the type of fire that we're dealing with, we have to actually know the type of fire to know which extinguisher to use. For example, if we have an electric fire, we're not going to use a class A, right? Because that is mostly based upon pressurized water. So we're gonna be spraying water on electrical fire, right? So this is where this section is actually important. So a class A fire, wood, paper, cloth, trash. So you can find this type of extinguisher in our office. We have those stuff that can easily be out with water. So that is a water extinguisher, class A. However, class B, flammable liquid, oil, grease, gas. All right. So as I can see, that has different characteristics of class A. We have our class C, electrical, energized electrical equipment. All right. And that is what we use on electrical fire. So I want this spray in B and that. All right. So class B. So even though we're working on electric vehicles, class C in itself won't be sufficient to actually extinguish electrical fire in this case, because if you look at class B now, it's combustible metals. And you know, we are gonna find like metals in the battery box, in our inverters, and the vehicle itself is metal. So once that caught fire, Class C in itself won't be of any use or any good. All right, and then Class F, it won't be necessary for what you're doing. But so for instance, you're at a garage or have a kitchen there, we can use a Class F, and that is for cooking oil and fat or greasy stuff that comes from the kitchen. And as well, we can have like a combination of these class, like from Class A to C. All right, so different kinds of extinguishers. The four most common fire extinguishers: all-purpose water, carbon dioxide, multi-purpose dry chemical, and dry powder. All right. So as we can see, the top one is clearly Class A, second Class B, and C, and D. All right, so all-purpose water used on Class A fires, pressurized water, and that has a pressure gauge present. So you can actually look at this extinguisher based on its character, the physical appearance of it. You can tell what type of extinguisher it is based on the nozzle, right? Type of nozzle that it has. It normally has a pressure gauge, right? Pressure gauge and a nozzle. And the carbon dioxide type, if you notice, used on Class B, Class C, or say used on Class B and Class C fires. All right, hard plastic nozzle, no pressure gauge. So if you notice, it has a hard plastic nozzle, and the way the nozzle is shaped, in comparison to the Class A, and it doesn't has a pressurized gauge. All right, so dry chemical extinguisher, and this is ABC. That's a combination. So use on Class A, Class B, and Class C fires. So one thing you can learn from this is Class A only used on Class A type of fire. Class B can be used on both Class A and C. Class C can use on AB as well as C. So you have a combination of A, B, C. All right, so fine powder under pressure. And we have a pressure gauge. So in appearance, it is similar to the water extinguisher, except for the color is in red, right? And you have the class right here in the information section. All right, and it may or may not have a hose or a nozzle in, and it has a pressure gauge. All right, so this is how we use our extinguisher. Aim it at the base and sweep. All right, so we have our pass method, PASS. Pulls the pin. That's what the P is for in this. All right, so this will allow you to squeeze the handle in order to discharge the extinguisher. Yeah, so we pull that pin. All right, the aim that now is the aim at the base of the fire. Aiming at the middle will do no good. The agent will pass through the flames. And first it's squeeze and pass. Squeeze the handle. This will release the pressurized extinguishing agent. All right. And once you squeeze, we're going to start to sweep. So sweep side to side. So we aim at the base and then we squeeze and sweep. So covers the entire area that is on fire. Continue until fire is extinguished. Keep on high on the area for relighting. So even though it might seems like it is out, we have to actually observe and make sure that we don't have ignition. And here we have like a scenario when not to fight a fire. So remember to keep an exit to your back. So as I said earlier, we keep the fire extinguisher close to an exit. So that way we actually are going facing the fire and having our exit at the back. So once our instinct tells us to run, we're gonna make our exit. So only fight a fire in the incipient stage. So that is in the initial stage. We're going to fight fire. So we're now gonna try to out a building that is already engulfed. All right, so important slides. All right, so never fight a fire if any of the following applies. You do not have the proper extinguisher or equipment. Fire has spread beyond its point of origin. All right. Your instinct tell you to get out. So, you know, once that fear starts to kick in, you just exit the building. All right. No need to try to be a hero, because all I'm gonna say is was a good youth, and that's it. All right, so emergency procedures. In the event of fire, call the nearest alarm station, immediately exit the building. If you hear an alarm, do not assume it's a drill. Your life may depend on it. All right, so sometimes we do like fire drills, but never take it for granted that it is just another drill. All right, so building evacuations. So procedure. All right, so proceed to nearest exit in an orderly fashion. Assemble at least 100 feet from building. Provide emergency crew with information about people still in the building. All right, so and I think within the fire drill, we normally can like label ourselves. Like one person can call himself one. So if we do a count and we find say right, number 10 is missing, we know so that person might still be in the building. All right, so provide information to the emergency crew about the reason for evacuation. So yeah, so if a person is in the building and them actually see what caused the fire, them can actually tell the fire personnel that, well, something in the kitchen did ignite, whether it's from stove, so then we know if it's an electrical fire or some other combustible material. So then we actually know how to approach that fire. All right, so I'm never re-enter a building until instructed. So instructed to by the police department. All right, so never re-enter a building until instructed by the police department, fire department, or EHS staff. All right. So once you have a fire, stay out until it is deemed safe to re-enter. All right, and with the electric and hybrid vehicle, these vehicles once they are ignite, especially in close proximity of buildings and other valuable property, they can actually cause like a wildfire. So we classify that as conflagration. Alright, so that is like fires in electric vehicles are known for being intense conflagration that are challenging for first responders to extinguish, meaning that the issue is likely to be a frightening one for current or prospective electric vehicle owners. So like, for example, in most cases when electric vehicle actually caught on fire, the rapid rate at which the fire spread in the vehicle and probably to nearby property, it can be frightening, right? So it's basically a very dangerous type of fire that can be started from these vehicles. So you know, you have like battery actually exploding and stuff like that. And we have other fires that can actually come from this. So we have deflagration and detonation. So deflagration wave propagates via the diffusion of heat and mass from the flame zone to effect ignition in the reactant ahead. And detonation, that is a wave. Detonation wave is a supersonic compression shock wave that ignites the mixture by a diabetic eating across the leading shock front. So when we say supersonic now, that's so rapid, this fire is going to spread, right? So basically in an uncontrollable way. So the shock is in turn maintained by the backward explosion of the reactant gases and products relative to the front, thus providing the forward thrust needed to drive the shock. All right. So but I think this one is what we're most commonly accustomed to, conflagration. So like overseas we call it like wildfire or bushfire. So it's a fire that spread over a large area. Right, and the other two is like rapid explosion. And we know that will come from the battery itself. All right, so I think that brings us to the end of this slide. So let's see if we can insert the other chapter. So give me a second.
Evening, everyone.
Evening, Mr. Basic.
Okay. How is everything going? How is the class coming along?
Getting more and more interesting.
More interesting. Well, would have normally had a different kind of group, but apparently Mr. James is moving much faster than we expect him to. So these slides were really designed for this session, However, it finished in 15 minutes earlier. So we're going to be pausing at this slide and moving into the next, come next Thursday, right, to pick up on the hybrid system. However, What I wanted to remind you of is that exam is going to be in December, and what I'd love for everybody to do is to send in the group the full name if you're interested in doing the exam, your full name that is including your middle name, no letter for the middle name, I need it spelled out, date of birth and email address. All right, because I need this to send to City and Guild so we can get an enrollment number. So
Okay.
it would be right, so it would be good to get that before the end of the week. The exam package is $10,000, equivalent I think is about £50. So all of that, so that what we normally do, we collect all and we pay one bank fee. I think the bank fee is to do a bank draft now is about $800. So if everybody put together, then we can just charge one bank fee for the whole group. Other than that, if you want to go ahead and do the draft, £50 draft, we can give you the address and you can return the draft to either us or City and Guilds. Right. So by mid-November, I want to get that out of the way. So I need the names and the address and the email address and the date of birth now. But for the exam payment, I need it by mid-November. That's about what? Next week after? Next week after. Right. So I can do the bank payment so I can get the enrollment number for the exam in December. I want to put the exam for the second week in December. Right. You can pick the day which I think is more convenient for you, considering work. So make a unanimous decision as to which day is more suitable for everybody and time. Right. I don't think everybody can come at the same time. So we want to set up in probably a 1 or 2 hour apart. So perhaps one set come 10, next set come 12, that kind of thing. All right. So work on that for me in the meantime. And again, thanks again for logging on and for the sacrifice that you make every time to be here. We appreciate it very much. All right. So all the best now to you and your family. Until next time, Thursday, God willing.
All right.
Have a
Thank you,
pleasant
sir.
night. Yeah,
Yes,
man,
sir.
sure. Have a good night.